Hello everybody, let's go ahead and start talking about circles. So this first part of this video, we're just going to be going over a bunch of different vocab. So what is a circle? We all know the general shape of a circle. We might know some circle facts. All right, but the pure mathematical definition of a circle is the set of all points in a plane that are equidistant. So they're the same distance from a given point called the center of the circle. All right, so the center is right here. And then if I draw out a segment that's the same length all the way around that center, I'm going to create a perfect circle. All right, so let's talk about some of these segments. So a radius is a segment whose endpoints are the center and any point on the circle. So all radii are going, that's plural for radius, all radii are going to be congruent. Because if I go here, or if I go here and draw this, these are going to be congruent. If I go over here and draw this radius, that's going to be congruent. All of those are examples of radii. Okay. Next up, we get a diameter. A diameter is a segment whose endpoints are on the circle and contains the center. So it must go through the center. All right. Something like this, even though it has endpoints on the circle, is not an example of a diameter. It's an example of a chord, which we'll get into later on in the unit. So a diameter has to go through the center, but it ends on the circle. Okay? Key fact, you may already know this, radius is half the diameter. A radius equals half the diameter. Okay? Or vice versa, the diameter is 2 times the radius. You can think about it either way. Doesn't really matter. Okay? And last thing for this is circumference. And circumference is the distance around the circle. So if I were to take this entire circle and I were to kind of break the circle so that it wasn't circular shaped, and I would just lay it flat against a ruler, that would be the circumference. That would be the distance around a circle. It's another way of saying it is the perimeter of the circle. All right, the perimeter of one revolution. So the distance one time around that circle is the circumference. All right, so that deals with some segments and then the circumference. All right, next up, let's talk about some angles. All right, now there are a couple different angles, ideas of angles that we'll talk about involving circles. The first of which is called a central angle. A central angle is an angle whose vertex is the center. All right, so our central angle is right here. All right, now, before we talk about those, the entire circle is how many degrees? The entire circle is 360 degrees. Doesn't matter what size of circle you got. You could have a circle this small, or a circle this big, or a circle even bigger. No matter what, it always has 360 degrees. All right, now that's not saying that the circumference is always 360. The circumference is going to change depending on the size of your circle. But no matter what, how many degrees are in your circle, it's always going to be 360. All right? So the central angle is just dividing up that 360. So this central angle is going to be part of 360 degrees. Could be 60, could be 70, could be 81. All right? So we got central angle. Next up, let's talk about a minor arc. So a minor arc is an arc whose measure is less than 180 degrees. So we see a minor arc right here. All right, the minor arc, if I wanted to name this, it would be arc, so a little tiny swoop, and then A, B, because it starts at A and ends at B. So that's the notation. That's how we label arcs. The measure of arc AB has to be less than 180 degrees. All right, and a key fact here is that the measure of a minor arc equals the measure of the central angle. All right, so if angle ACB is 60 degrees, that arc, the measure of that arc is going to be 60 degrees. So the measure of the arc equals the measure of the central angle. All right, now let's talk about major arc. So a major arc is the other arc, other than the minor arc. All right, in this example at least. Here's an example. If I draw this, boop, 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 that's your major arc. So that arc is going to be greater than 180 degrees. All right, and the notation for this major arc, I'm going to use 3 letters now. It starts at A, goes through D, and ends at B. All right, that kind of looks like an O. Let me rewrite that. A through D, so D's right here, and then ends at B. And the measure of that arc, the measure of arc ADB is going to be greater than 180 degrees. All right, and to find the measure of it, if I wanted to find the measure of arc ADB, I would take 360 minus the measure of the central angle. Because like going back, if that angle, ACB, the measure of that angle is 60 degrees, then the minor arc is 60 degrees, which makes the major arc 300 degrees. Okay? So last kind of angle and arc we need to talk about is a semicircle. So a semicircle is an arc whose endpoints are the endpoints of the diameter. So like here, it starts at A, goes through C, and ends at B. A and B are the endpoints of the diameter. So the notation of this, I'm going to use 3 letters again. It's going to be A, C, B. And the measure of this arc, the measure of ACB, is 180 degrees. All right, it cuts the circle in half. So it's going to be 180 degrees. So with these arcs and angles, with a minor arc, use 2 letters to name it. For a major arc, use 3 letters. And for a semicircle, use 3 letters. Okay? You may see a semicircle with 2. I prefer to use 3 letters though. Okay? So a minor arc has 2 and a major arc has 3. All right? So that's kind of an idea of a lot of vocab that's circles that we'll be using with circles. So just make sure you study this page and understand each of these vocab words. All right? In the next video, we'll start to use this vocab, use these ideas, and start to solve some problems. Make sure to hit up those next videos to get the rest of your notes.